When we click on the Biospectrogram icon on the desktop, license window opens. When you accept the license window, a message appears telling you that the license has been accepted. When you click OK, it will ask you for your total RAM. Enter your total RAM, then click OK. The Biospectrogram window will open. The various options available are display, import and fetch for data collector, encode for encoding, transform for transforming, and export and plot for exporting and plotting your output. Window analysis option is also available. Other miscellaneous functions available are home, back, manual sequence, preferences, where you can set your various preferences like fonts. Just when we click on preferences, various options are seen. You can change any of them and click OK. Thereafter, internet is used for checking your internet connectivity. Your internet connection is up. So first of all, you would like to start off by downloading a DNA or a protein sequence. For that, you will click on fetch. It will display a note. After reading it, click OK. Then it will ask for accession number of the DNA sequence. Enter accession number. I am entering accession number MC001802, which is of HIV virus. When we click on OK, a dialog box will be displayed indicating that it is fetching. Now it has fetched already. Click on OK. Both the files are fetched and their paths are displayed, and the file will be displayed in the upper pane, as you can see here. Now you can encode this entire sequence. This will be FASTA file will be highlighted in the first drop down menu. In the next option, you can select various encoding schemes. As you can see, for testing purpose, we are selecting indicator encoding. Clicking on OK, it will ask for which character is to be encoded. If you select A, A will be encoded as 1 and rest of them will be encoded as 0. And message will be displayed indicating that the file has been generated along with its path. And it will also be displayed in the lower pane, as you can see. You can resize the panes as and when you want. Thereafter, you can click on the transform. As you see, the name of the file you just encoded will be first in the first drop down menu. You can apply various transformations on it. Here, as you see, the codes, first few characters is the same as accession number, and the next one, as you see, is the encoding code. You can see various encoding codes by clicking on convention. As you can see here, naming conventions from help menu. When you click on it, a PDF file will be displayed indicating various conventions of the namings of encodings and transformations. So this will be handy and you can refer to it at any time you want. Now when you click on the transform button and you want to perform a fast Fourier transform on the indicator encoded file of HIV virus, you click on OK and transforming will be displayed here. After the transformation file, completion message will be displayed here. Clicking on OK, the encoded file will be displayed in the upper pane and the transformation output will be displayed in the lower pane. Now you can export this file using export button. Now you can export encoded file or the transform file. Here we have already created the transform file, so we will export the transform file. We will select the transform file and then click OK. A MATLAB script will be generated which will plot the transform file and its path is shown here. Now as you can see, there is a display button. You can display any of the files you want. Suppose I want to display the gene bank file. You can select the gene bank file, click on OK and the file will be displayed here. You can also import file which can be at any destination on desktop or in the history folder. When you click the import file, the history folder will be on by default. You can also import the file from any other folder by browsing from here. Here I select the user.abc and user_abc file, and it is imported. And you can see file is uploaded to the history and fetch folder, and it will be displayed here successfully. Now you can also use a manual sequence option. You can, first of all, you need to select a sequence, any sequence you want. If you want a subsequence of the displayed sequence, you can select it, copy it, and in the manual sequence paste it and click on OK. You can give a file name test, and it will be saved as user_faster. Now you can use this file to do encoding, transformation, etc. So you can use indicator encoding. Many options are there. Thereafter, NCBI update. It updates all the files in the history folder from the NCBI website. It checks if they are up to date or not. It downloads them and replaces the old files. So this notice will be displayed here. When you click on OK, the confirmation button will be asked. Confirmation will be asked you whether you want to continue with it or not. If you click on yes, it will update all the files. It will download if the files are not up to date, and history will be updated successfully. Now you can also see there is a switch to AA button. AA stands for amino acids. When you click on it, we go into the amino acids mode, and as you can see, fetch, window and NCBI updates are disabled. These features will be supported later. Right now you can import any file, you can display any protein file, and so on. When you click on display, user_prot.file is shown. You can click on OK, and it will be shown here. You can perform various tasks on it. You can perform encoding. You can click on display. You need to display the gene bank file. You can see that there are some proteins here. You can just copy any protein, a subsequence of the protein from here. After switch to amino acids for the protein mode. Thereafter you can go to manual sequence, paste it here, click on OK, give the name test1, and it will be saved. Now you can perform any of the operations, encoding, transform on this subsequence. Like various options available here are indicator encoding, electro-ion encoding, and random real value encoding. Suppose we choose random real value encoding. It will ask if you want to enter the values. If you don't enter, I click on no, and random values will be generated, which will be displayed here. Once it is over, you can see successfully generated message will be displayed. Thereafter, the file will be displayed in the lower pane. So you can also, all the encoding, whatever A is mapped to 0.06, C is mapped to 5.2, that you can see in the bracket the first line of the file which is generated, so that you know which AC, GD, etc. are mapped to which real numbers. You can see from the first line. Thereafter you can go to encode. I already encoded, so we can go to transform. This is the file which we encoded. You can apply fast Fourier transform on it, and the file will be generated successfully. After, you can, in the similar fashion, export it, export transform file. You can choose to export it, and the file will be successfully. You can go to this path, open this file in MATLAB, run it, and it will plot the output of the particular transform which you have selected. Thereafter, there is also back button, which will take you to the previous display on both the panes in case you want to refer to the previous sequence, as in our case currently. You also have a home button. Home will take you to the display of the latest downloaded file, as you can see here, HIV virus, which we downloaded the latest. All these options we have already seen. We go back to DNA mode. There is also a clear history option. If you click yes, all the history will be deleted. Right, I'm not deleting it. Thereafter, there are tools and help menu. Tools menu has almost the same options as there are buttons, as you can see here. there is an exit button which will close the entire application. Other than that, all the buttons are there already displayed. In the help menu, you have the user manual option. If you click on it, user manual will be displayed and you can refer to various things there if you are not sure how to use it. There is a software update option. When you click on it, it will take you to the home page of the download for the software. So if there are any updates, you can download it from there. Naming conventions we already saw. If we click on about, it will show various version of the current software, the website, that's the home page, and it will show the credits. If you click on credits, you will see the whatever contributions are there. So this is pretty much all about the software. Picking up where we left in the last video, we can see that window analysis option is available here. If we choose the file which we downloaded in the last video and we choose to do sliding window analysis or stagnant window analysis or gene prediction, sliding window analysis will allow you to size the window, asking you for starting index and the end index, and you can slide the window over the entire sequence and you can perform whatever encoding and transformation you choose to apply on them, and the plot file plotting all of the Windows outputs will be generated. That is the MATLAB script. You can run the MATLAB script which will plot all outputs of the transformation files one by one automatically with a given delay which is set already by default. You can change that delay in MATLAB plot from the preferences. Right now, if we select when we go to the preferences window, there are various options available. In fetch history, you can change the number of files which will be saved in the fetch history. As you can see here, right now it's 50, and you can change the maximum size to anything. If the file size increases from there on, the earlier files will be replaced and new files will be saved there. Similarly for the encoded history, transformed history and the protein history. You can change the font size from here. Suppose we make the font size to be 20 and click on OK. Font size will be saved and you can see the font size has been changed. Also, if we make the size say 50, then the font size will be really big. So we'll go back to 30 for the font size. Now, as we are seeing in the preferences window, this is the value where we can enter the delay in the MATLAB plot. When the automatic plotting of the transform file outputs will be shown, the delay between the two plots can be set here in seconds. Also, you can set the RAM size in GB which will be used for Biospectrogram. 25% is the actual optimal as you can see here, but you can also set more than that, up to 60%. Let's try this one. We set the RAM size to 1 GB. Actually the RAM is of 4 GB, so this is the optimal one. When we click on OK, it will change the RAM size, and when we click on OK, it will run it again, and Biospectrogram window will be seen again with 1 GB RAM allocated to it. So this way you change the various preferences here. Suppose you enter a RAM size which is greater than 60% of your actual RAM. Say we enter 4 GB and our RAM was 4 GB. It cannot allocate the entire RAM. So when we click on OK, it will display the message that it is more than 60% and hence cannot allocate that much RAM. Hence you can use these preferences. Now going back to the window analysis, we choose to do the sliding window analysis here. When we click on OK, it will display the number of characters in the file. Thereafter, it will ask if you want forward sliding window or the backward sliding window. Right now we choose forward sliding window. Then we can choose the encodings and transformations which we want to apply on the window, which is the subsequence of the entire sequence. Say for example we want to apply tetrahedron encoding, and or let's say we want to apply an indicator encoding and a fast Fourier transform, and click on OK. It will again display the characters. Then it will ask if we want a single window size or a range of window sizes. If suppose we enter 50 to 56 as the range of window sizes, then it will get the output for each window size. Right now we choose a single window size and we choose a window of size 300. Click on OK. It will start calculating the Fourier transform in the window given window size, and the percentage completion will be shown here. When we wait for its completion, as you can see, the performance has reached nearly 90%. Now it will complete in few seconds. After that, a MATLAB script will be generated. The message will be shown indicating the destination of that MATLAB script, the path where it is saved, and from there you can plot the entire transformation files for each of the window, and you can compare them and find out various characteristics from them. It's near to completion. And it's complete. As you can see, the path of the file will be displayed here. It will be saved in history window analysis folder in MATLAB files, and the notation here W300 indicates that 300 is the window size and NC001802 is the accession number of the DNA sequence. E01_1_3 indicates the indicator encoding, and T01 indicates the transformation, which is the fast Fourier transform which we have selected. And this will, running this MATLAB script will plot all of the plots for each transformation output for the window sizes. If you have chosen multiple window size, or for just a single window size, it will plot all the windows subsequences of the given sequence in a consecutive manner, and the delay which you have chosen in the preferences will be the delay in seconds between each plot. As we click on OK, so we come to an end for the tutorial for using this Biospectrogram software. We wish you all the best for and enjoyment for exploring the use of Biospectrogram for finding the characteristics of DNA and protein sequences using the spectral analysis of the biological sequences. Thank you.
Hi there, this is शेयर का ऑप्शन है, शेयर बताइए, ये पहले ख़त्म करना पड़ेगा एंड ब्रॉडकास्ट किया मैंने वैसे, देखें क्या बना है, राइट। तो बहुत टाइम लगा रहा है, मतलब आई डोंट नो सेविंग और नॉट सेविंग क्या करना है। ऐसा करते हैं, उसी में बना लेते हैं और रिकॉर्ड कर लेते हैं सिंगल स्ट्रेच में, तो भी बेटर रहेगा ना, उसको पॉज भी कर सकते हैं। लो फेल टू एंड ब्रॉडकास्ट। Hi there, this is